Okay, so let's start with this. So in the last class, we talked about the basic concepts of equation of circle. This was the standard form that we came up with: x minus a whole squared plus y minus b whole squared equals r squared. That's the general form for the equation of circle. All right. Now a and b are the coordinates of the center of the circle. R is the radius. So in order to write down the equation of uh, a circle, you need two things. You need the coordinates of the center and you need the radius. If you have those two things, you can write down the equation of the circle. All right. We looked at different examples of this. In particular, this was important when you have the equation of a circle given, especially in expanded form, and you have to find the radius of the circle and the coordinates of the center of the circle. All you have to do is complete the square for x terms separately, for y terms separately. Once you're done with completing the square, you convert it to the standard form with constant on the right side and these two squares on the left side, compare it with the standard form, and you get the coordinates of the center and the radius, right? That's what we did. Then we talked about angle properties of circle. They're still used in this topic as well. You need to keep that in mind. And then we looked at this idea that if you have three points given that lie on the circumference of a circle, if the circle passes through these through these 3 points, how can you find the equation of the circle? Now, the main problem here is finding the center of the circle. And how do you find the center of the circle? You basically use this idea that the perpendicular bisector of every single chord in a circle, perpendicular bisector of that, it has to pass through the center of the circle. So if you basically find the equations of any two perpendicular bisectors, find the perpendicular bisector of one chord, find the perpendicular bisector of another chord, just solve those two equations simultaneously, you would get the coordinates of the center of the circle. All right, so that's the process that we have for finding the center. Once you have found the center, then you just have to find the radius by calculating the distance of that center from any of those 3 points that you have, and you can write down the equation after that, right? So that's what we did. That's pretty much all that you need to know about as far as the equation of circle is concerned. You have to use, along with this, the other concepts that you've done in coordinate geometry, and sometimes some concepts of quadratics as well, because in a way, the circle equation is also a quadratic equation, right? It's not the standard form ax squared plus bx plus c, but it's quadratic in the sense that the highest power is 2. So when you try to solve circle equation simultaneously with another equation, a lot of times you end up getting quadratic equations. So you do need to sometimes use concepts of quadratics here as well. But as far as equation of circle itself is concerned, these are all the concepts that you need to know about that. Okay. Now let's start with some questions. So first of all, let's start with the one that Hazim is asking about. Question number 2, part C. Let's start with this one. Okay, so we're saying question number 2, part C. Let's try this. Okay, so now since it's the first question that we're doing from the worksheet, let's actually do it completely. We'll try to be quick about the first 2 parts because that's not what you have a problem in. Let's start with this. So it says the circle C has center A with coordinate 7, 5. So we have the circle. This circle is named C. The center of the circle is at the point A. The line L with equation y equals 2x plus 1. So they've given the equation of the line L is tangent to C at the point P. You can see that this line is the tangent to the circle at point P. Show that an equation of the line PA is 2y plus x equals 17. So what's PA? PA is basically this line that comes from P to A. It's a line that looks like this. Okay. Now, if you think about it, PA is basically the radius of the circle at the point P. So at the point P, PA represents the radius and the line L represents the tangent. Remember, radius and tangent are supposed to be perpendicular to each other. So these two lines are perpendicular to each other. So if you have to write down the equation of the line PA, you need two things. You need the gradient of the line PA and any one point on the line PA. Now, do you have a point on line PA? You know the point A. The point is 7, 5. So you can use that. So you have 1 point. Point A is 7 and 5. And you also know that the equation with line L has this equation, y equals 2x plus 1. If this is the equation of that line, what's the gradient of this line? If you compare it with y equals mx plus c, in place of m, you've got 2. So the equation, so the gradient of line L is basically 2. All right. So we can say gradient of line L, that is basically 2. Now, if the gradient of line L is 2, what about the gradient of PA? It's perpendicular to that. So it's going to be negative reciprocal. That's minus 1 over 2. So you have the gradient of the line PA, and you have a point that lies on the line PA. That's point A. You can write down the equation. You can say y minus y1 equals m into x minus x1. Just use that and write down the equation of this line. Y minus y1 equals m into x minus x1. We've done coordinate geometry before. Just input values in this. Y minus 5, that equals minus 1 over 2 into x minus 7. And that's the equation that we were looking for. We have to prove that it's of this form. How do you prove it that it's this form? We need a constant on the right side, x and y terms on the left side. So let's convert it to this form. You need to get rid of the fraction as well. So you can multiply 2 on the left. If you multiply 2 on the left side, that gives you 2y minus 10. On the right side, minus x plus 7. Bring x to the left side, that gives you 2y plus x. 10 goes to the right, and that gives you 17. 2y plus x equals 17. That's what we wanted to prove. We've got the equation of the line PA. Okay, that's the first part. Now, in the second part, it says find an equation for C. Find an equation for C. That's the circle. We need to write down the equation of the circle. Now, what do you need to write down the equation of a circle? You need two things. Coordinates of the center of the circle. We already have that. We already know that the point A has these coordinates, 7 and 5. The other thing that you need is the radius of the circle. How do you find the radius of the circle? We don't have the radius given. Any idea about that? How do you find the radius of the circle?
Radius equals the length of PA.
Radius equals length of PA, but how do you find the length of PA?
Find the coordinates P, we already have A, so make both equations equivalent.
Yeah, so P is the point of intersection of the line L and the line PA. So what we first have to do is we have to find the point P, the coordinates of the point P. How can we, so because once we have the coordinates of the point P, then we can just find the distance between point A and point P, right? And that will be the radius. So how do you find the point P? For finding point P, you can just solve these two equations simultaneously. Y equals 2x plus 1 and the equation of the line PA. Solve them simultaneously, and that's going to give you the point P. So the first equation is y equals 2x plus 1. And the second equation that we have here is 2y plus x equals 17. Solve them simultaneously and see what that gives you. So I can input y equals 2x plus 1 in the second equation. What does that give us? 2 into 2x plus 1 plus x equals 17. And that gives us 4x plus 2 plus x equals 17. 5x equals 15. The value of x turns out to be 3. Put that back in this equation. Y equals 2 into 3 plus 1 and y equals 7. So the point P therefore has these coordinates 3 and 7. So if we can find the distance of PA now, that will be the radius. Let's find that distance. Radius equals the distance PA, right? That's going to give us the radius. So that's square root of, so point P is this. What's the point A? Point A is 7, 5, right? That's point A. Let me just write that here as well. Point A is 7 and 5. 7 minus 5 whole squared plus 3 minus 7 whole squared. X2 minus x1 whole squared plus y2 minus y1 whole squared. Take square root of that whole thing. What does that give you? 4 plus 16, that's 20. Square root of 20, that's the radius. That's what we were looking for. So now we've got the radius and we have the coordinates of the center. Center is this, radius is this. You can write down the equation of the circle. You can say x minus a whole squared plus y minus b whole squared equals r squared. Just input values. This is supposed to be A, this is supposed to be B, and this is supposed to be the radius. X minus 7 whole squared plus y minus 5 whole squared equals r squared. That means square root of 20 whole squared. That gives you 20. And that's the equation of the circle that we were looking for. Okay, that's the second part. All right, we had to find the equation of the circle. For that, we needed a point and the radius. We needed the center and the radius. We already had the center given. We just found the radius and wrote down the equation of the circle like that. Okay. All right, that was part B. Now let's look at part C after this. Okay, so now it says the line with equation y equals 2x plus k is also a tangent to C. Find the value of the constant k. So now there's another tangent to the curve, to the circle that has this equation, y equals 2x plus k, where k is not equal to 1. Now, why k is not equal to 1? Because if k was equal to 1, you would get the same equation as before, y equals 2x plus 1. That's the first tangent that you're already given. This is one tangent. We already know that's y equals 2x plus 1. So if k was equal to 1, you would get that same tangent. That's not what we want. We have another tangent that has an equation like this, y equals 2x plus k. Now, what do we know about this tangent? Now, there are many possible tangents to this circle, right? You could have a tangent like this. You could have a tangent like this. You could have another like this. Right? There are many possible tangents to the circle. Do we know the gradient of this tangent that they've given? What's the gradient of this tangent? What's the gradient of this tangent? Y equals 2x plus k.
2.
It's 2, right? And the gradient of the previous tangent that we had, that also has, that's also 2. Gradient of the previous tangent, that's also 2. So basically this other tangent that we're talking about, it has to be parallel to this first tangent. So where is that going to be? Now, you want another line parallel to this line. That's a tangent to the circle. Where would that line be? It would have to be on the other side like this. You'll have another tangent on this side of the circle. Exactly opposite to the point P, somewhere around here. This is where the tangent is going to be in this case. Make sense? This is going to be y equals 2x plus k. What we need to do is we need to find the value of this k. Now, how can we find the value of k? Let's try to figure this out. Now, you see, it's exactly on the other side, this tangent and this tangent, they are parallel to each other. The radius that we draw at this point, that's also going to be perpendicular to this tangent. Let's call this point something. Let's call this point x, for instance. The tangent at point x, that's going to be perpendicular to the radius at the point x, right? That tells us that this line, px, that's a straight line for which A is the midpoint. So this line looks like this. We have a line like this. There's one point P, there's one point X on the other side, and right in the middle, we've got the point A. That's the midpoint of P and X, right? That's what the situation becomes. The other tangent is going to be exactly on the opposite side like this. Now, do we know the coordinates of P? We have found that in the first part. Coordinates of P, they were, in fact, in the second part, they were 3, 7. So we know the coordinates of P, 3 and 7. We know the coordinates of A, they are 7 and 5. We first need to find the coordinates of the point X. As in, what point is this tangent at? What's the point where you're basically drawing this tangent? Can we find that point somehow? Given that we know that point A is the midpoint of Px, we could use the midpoint formula if we wanted. That's one idea. You could call the coordinates of point X, X and Y, find the midpoint of Px and say that that's supposed to be equal to 7 and 5. We'll get two equations and we'll find the values of X and Y. Or a quicker way to do this would be the vector method that we did in coordinate geometry earlier. You have a point P that's 3, 7. You have a point A that's the midpoint of P and X. And you have a point X for which you need to find the coordinates. All you have to do is you just check, okay, how many units do you have to go, how many units do you need to go from 3 to 7? You need to add 4. You would add 4 more to get to the point X, and that gives you 11. How many units do you need to go from 7 to 5? Minus 2. You'll do minus 2 more to get to this point X. So the coordinates of point X, therefore, are supposed to be 11 and 3. Or you could use the midpoint formula as well to find those coordinates. We have done this in coordinate geometry. The idea is whatever is the horizontal distance here from P to A, it's supposed to be the same from A to X. Similarly, whatever is the vertical distance here from P to A, it's supposed to be the same from A to X. So that's where we can use this idea, the vector method. We find the coordinates of the point X. And now that we know the coordinates of the point X, the tangent to X looks like this: y equals 2x plus k. X is a point that lies on this tangent, right? This tangent that we have, y equals 2x plus k, X is a point that lies on this tangent. What we can do is, we can input that point X in this equation because it has to satisfy the equation if it lies on the line. We can just input that point here. We can put 11 and 3 here, and that gives us 3 equal to 2 into 11 plus k, and the value of k turns out to be minus 19. And that's what we were looking for. K is supposed to be minus 19, right? And that's what we wanted to find. Is that okay?
Yes, sir.
No problems with this? Okay, now let me know if there are any other questions from the worksheet. Other questions from the worksheet. No. Okay, so what I'm going to do is I'm going to choose a couple of questions myself, and we will try to do those questions. And then what you're going to do is you're going to try the rest of the assigned questions on the worksheet as well. And then we could see them later if there are any further problems. Okay, so let me find a question that we could have a look at right now. Okay, so let's try this. Okay, by the way, there are some questions in which they would ask you to do something like this. Now, it's not specific to circle equations as such. It could come in some other topic as well. I just need to make sure that you understand this terminology. So sometimes they ask you to give your answer as simplified surds. Now, first of all, what is a surd? Surd is basically square root. Surd basically means square root form. So something like this: square root of 3, square root of 5, square root of 8, right? These are called surds. That's another name for this. All right. In fact, I think it includes cube root, etc. as well, not just square root. Let me just confirm this. So irrational numbers, but oh yeah, so it does include the other roots as well: cube root, fourth root, fifth root, sixth root, anything like this, right? So it could be a cube root as well, it could be a fifth root as well, anything like this. These are called surds. All right. Now sometimes they ask you to give your answer in surd form. All right. All that means is you do not need to write your answer as a decimal. Whatever is the exact form, you just have to write it like that. Okay. Now, not the square root, it could be cube root, fourth root, fifth root, any root. That's called surd. Now, sometimes they ask you to give your answer as simplified surds. Now, what does that mean? So let's say, for instance, you have square root of 200, right? Now, this is not a simplified surd. Simplified surd is that if there's any perfect square that you can write outside the square root, you should do that. So square root of 200, for instance, what you have to do is look at the factors of 200. Start from the largest factor. Look at the largest factor of, think of the largest factor of 200. That's a perfect square. So what are the factors of 200? Start from the top. What's the largest factor? 200, is that a perfect square? It's not. Okay, what's the next one? 100, is that a perfect square? Yes, 100 is a perfect square. What you're going to do is, you're going to break this surd down into two parts, 100 into 2. And then 100 could be written as 10 squared. So you have 10 squared into 2. Now 10 squared and square root, they get cancelled. And you're left with just 10 outside. And inside you have square root. This is called a simplified surd. Square root of 200 is a surd. 10 square root of 2, that's a simplified surd. All right. So the idea is, whatever is the number inside, you break it down in such a way that you see what's the largest factor of that number that is a perfect square. And then you could write that outside like this. Now, let me take another example. Let's say you've got something like this. You have square root of 125, for instance. Now, think of the factors of 125. You've got 125, 25. 25 is a factor of 25 is a perfect square. So if you break it down like this, you can say it's 25 into 5. And now it could be 5 squared into 5. And 1 5 could be written outside. So square root of 125 is the same thing as 5 square root 5. This is a simplified surd. Now you don't have to do all of this manually. Your calculator can actually do it for you. So whenever it says that your answer needs to be a simplified surd, if you're getting something like this, square root of 200, just put that on your calculator. But put that on your calculator, put 200 square root on your calculator. Your calculator is automatically going to give you this form, 10 under root 2. You'll get this form directly on your calculator. So you don't have to do it manually. Your calculator will do it for you. Okay. So when it says simplified surd, now you know what that means. All right. Okay. Now let's go back to some more questions from the worksheet. Okay, let's try this one for instance. This is question number 21 from the worksheet. It says the equation of a circle is x squared plus y squared minus 4x plus 6y minus 77 equals 0. We need to find the x coordinates of the points A and B where the circle intersects the x-axis. Where the circle intersects the x-axis. So what does that mean? That's the x-intercept, right? So we're looking for the x-intercepts of this circle. How do you find x-intercepts of any function, of any graph? You put y equal to 0. So that's exactly what you're going to do here. You're going to say x squared plus y squared minus 4x plus 6y minus 77 equals 0. Put y equal to 0. What does that give you? That gives you x squared plus 0 squared minus 4x plus 6 into 0 minus 77 equals 0. And you have a quadratic equation like this. X squared minus 4x minus 77 equals 0. And now you need to solve this quadratic equation. You can't write down the answers directly. You have to make sure you either show factorized form or you input values in the quadratic formula. You have to do at least one of those two things. Now, can we factorize this? 77, 10, 11, 7. Yeah, so 11 and 7, they could work. Minus 11x plus 7x minus 77 equals 0. And that gives you x minus 11 into x plus 7. These are two factors that you have. X equals 11 and x equals minus 7. Points where the circle intersects the x-axis. Okay, that's what we were looking for. X equals 11 and x equals minus 7. These are the x coordinates of those 2 points. X coordinates of the x-intercepts. Okay. Now, what about the second part? Now it says the points are A and B. Now, we don't know which one of them is A, which one of them is B. It could be any one of them could be A, any one of them could be B. So that's okay. We don't need to specify anything here. Now it says find the point of intersection of the tangents to the circle at A and B. Okay, point of intersection of the tangents to the circle at the point A and the point B. Now, what does that mean? Let's try to understand the situation. And this is going to be very helpful whenever you have circle equation questions. Draw a rough sketch to try to understand the situation better. So let's say you've got a circle like this. What do we know about this circle? We know that there are 2 points which are the x-intercepts of the circle. Now, where exactly are those 2 points going to be? Are they going to be like this? Is the x-axis going to be like this? Is the x-axis going to be like this? Or is it going to be like this? How do we know that? Is most of the circle below the x-axis or above the x-axis? Or is it right in the middle? We can't be sure at this point. All right. So since we want to find the equations of the tangents, in order to find the gradients of the tangents, we also need the center of the circle, because then we can find the gradient of the radius, then use that to find the gradient of the tangent. So we also need the center of the circle. Now, how do you find the center of a circle from its equation? Remember that you have x squared plus y squared minus 4x plus 6y minus 77 equals 0. Now, the proper way of doing this was that we would complete the square on both sides, complete the square for x term separately and y term separately, take the constants to the right side, convert it to standard form, and then you see what the center's coordinates are. Or finding the center's coordinates is actually quite straightforward in the sense that you can do it mentally as well. All you have to do is look at the coefficient of x, divide it by 2, that's -2, and change its sign. It's going to be 2. Y, coefficient of the y term, that's 6, divided by 2, that gives you 3, change its sign, that's -3. This is going to be the center, the coordinates of the center. All right, just divide it by 2, flip the sign, the coefficient of x and y, because that is what you're going to get eventually when you complete the square. So if you wanted, you could write it out like this directly, but if you think you'll forget this, just follow that standard process. Write the x term separate, x square minus 4x, write the y term separate, y square plus 6y, and on the other side, you could take the constant. So on the other side, you've got the constant, that's 77. Now complete the square for x and y separately. You've got +2 squared and -2 squared. And here you have +3 squared, -3 squared. And that gives you x -2 whole squared. And you have this -4 outside. Plus y plus 3 whole squared. You have this -9 outside. Equals 77. So the equation of the circle turns out to be x -2 whole squared plus y plus 3 whole squared equals 90. Compare it with the standard form. What's the standard form of the equation of a circle? X minus a whole squared plus y minus b whole squared equals r squared. The center is going to be 2 and -3, right? That's what the coordinates of the center turn out to be. So now let's say this is the circle that we're talking about, and the center is right here. We know the coordinates of the center. The coordinates of the center are 2 and -3. 2 and -3. The y coordinate of the center is negative. That means center is below the x-axis. So where is the x-axis going to be? X-axis is going to be above the center. So it's going to look something like this. This is your x-axis. Okay. And we know the coordinates of the x-intercepts. We know that this point is supposed to be 11. And this point, the other point, that is supposed to be -7. Okay, no, the other way around. -7 should be on the left side, 11 should be on the right side. -7 is a smaller number. So -7 has to be here. 11 is the bigger number, so that has to be here. These are the x-intercepts. And we know the coordinates of the center now as well. Okay, so that's what the situation looks like. Now, what they want us to do is, they're saying one of these points is A and the other is B. Let's call this A and this B. It doesn't matter. You could do it the other way around as well. It doesn't make any difference. It says find the point of intersection of the tangents to the circle at A and B. Now, if I were to draw a tangent to the circle at A, it might look something like this. And the tangent to the circle at the point B, that might look something like this. This is what the tangents are going to look like. Okay. This is what the tangents look like. We are looking for the point of intersection of these two tangents. So this is the point of intersection. Let's call this point X. We want to find this point of intersection of these two tangents. Now, how would you think about that? One idea is that you could find the equations of both the tangents separately, solve them simultaneously, and that's going to give you that point of intersection. That is one possibility. All right. How do you find the equations of the tangents? You could start by the equation of this first tangent, tangent at A. Let's think about that. Tangent at the point A. You need two things to write down the equation of a line. One is a point. Now you have the point A, that's -7, 0. The other thing that you need is the gradient of that line. How do you find the gradient of this line? What you can do is you can find the gradient of the radius, gradient of this line. Gradient of that tangent is going to be negative reciprocal of this value. Okay, let's find the gradient of this radius. Let's call the center something as well. Have been named it anything? No. We can call the center C, let's say. Okay. Now let's find the gradient of the radius, which is AC. y2 minus y1. Now the coordinates of the point A, they're -7 and 0. Coordinates of B are 11 and 0, right? So my y2 minus y1, we can say -3 minus 0 divided by x2 minus x1. That's 2 minus 7. That's 2 plus 7. And that gives me -3/9, which is -1/3. Then what about the gradient of the tangent? It's going to be negative reciprocal of that. So it's 3. So what's the equation of this tangent now? Y minus y1 equals m into x minus x1. Just input values. Y minus -7. So that's y minus 0. This is x1. This is y1. This is m. Y minus 0 equals 3 into x minus -7. That becomes x plus 7. And the equation of this tangent turns out to be y equals 3x plus 21. That's the equation of the first tangent. We need to find the point of intersection of the two tangents. Now, how can we do that? We can find the equation of the other tangent as well in a similar manner, and then solve these two equations simultaneously to find the point x. Now, is there a quicker way of doing this? Do you think there's any quicker way of doing this? Can we find the point x without having to find the equation of the other tangent? That could be one possibility. Yes, you could find the equation of the other tangent, solve the two equations simultaneously, and that will give you the result. But could we do it without that? Any idea about that? Think about it. Remember the circle property? You have two tangents coming from outside the circle. Point x is a point outside the circle. You've got two tangents coming from that point. One tangent is on this side, the other tangent is on this side. If you were to join both of those points with the center of the circle, this shape is a kite, right? This shape is a kite. Now remember the properties of diagonals of a kite. Diagonals of a kite are perpendicular to each other. So if AB is horizontal, what about CX? That is supposed to be vertical. So if CX is vertical, that means the y coordinate of x is already known. The y coordinate of x has to be -3. Sorry, the x coordinate of x is already known. X coordinate is supposed to be 2. It's only the y coordinate that we do not know about, because the x coordinate of C and x, they have to be the same, because they both lie on the same vertical line. Because it's a kite, the diagonals are perpendicular. If AB is horizontal, AB is the x-axis, then this line CX, it has to be vertical. That means C and X have the same X coordinate. Now, if they have the same X coordinate, that means the X coordinate of X, the point X, is 2. What about the corresponding Y coordinate? We can just input that value here, put X equals 2 here in the first equation of the tangent. And that gives you Y equals 3 into 2 plus 21, and Y turns out to be 27. So the point X that we were looking for, the coordinates of that point, therefore, are 2 and 27. And that's what we were looking for. Okay. Since AB was horizontal, we could figure out that XC is supposed to be vertical. And from that, we found the x coordinate of that point already. Then we could just input that x coordinate in the equation of the tangent that we found, because point x lies on this tangent as well. So it has to satisfy the equation of that tangent. We put x equal to in that, we get the corresponding value of y. And that's what we were looking for. The other idea could be that you found the other tangent as well. Then you solved the two equations of the two tangents simultaneously, and that would give you the point x as well. That could be another idea, slightly longer, but that could also work. Any problem with this? Any questions? No?
No, sir.
Does anyone have any other questions from the worksheet? Or is that it? Okay, so I think it's not really going to be very helpful if I just explain the rest of them like this, because if you haven't attempted them first, then I think it's a bad idea to explain to you directly that what exactly you have to do with those questions. I would recommend that you attempt these questions then. So there are some questions that I definitely want you to attempt in particular. And then we could have another class at some point next week. Or tomorrow we could start APGP. Okay. But next week, at some point, we will have another practice class on equation of circle. And by that time, I expect that you would have done all those assigned questions, so you know which other questions you're having problems in, and then we could discuss them. Because I want you to think about those questions yourself first. Then it would make sense for me to explain them. All right. So question number 19. This is a good one from the worksheet. Question number 19. Do have a look at this. Question number 19 from the worksheet. Question number 16, 19, 16, 6, and 22. So these are 4 questions that I expect you to attempt before we have another class on circle equations in which we do some more practice. You need to have done these 4 questions at least these 4 questions, ideally all the assigned questions, but at least these 4. Okay, let me repeat: 19, 16, 6, and 22. Can somebody post these on the WhatsApp group as well? And in fact, also 18. Add one more to it. 18 as well. I'm going to write them here. Please post them on the WhatsApp group as well. 19, 18, 16, 6, 22. Yeah, all of these look like good questions. So you need to make sure that you attempt them, and then we'll discuss them in the next practice class that we would have on circle equations. But in terms of concepts, we're done. So you should be able to attempt all of these at least, and then we'll discuss them. All right. Tomorrow, or not tomorrow, so we might have a class tomorrow as well. So can I have raise of hands from those of you who will be fine if we have another class tomorrow as well on Sunday? Can I raise of hands if you're okay with that? Because then we'll have an Eid break for a few days. I want to get done with APGP before that as well, so that we're done with the concepts at least, and then if we need, we could have maybe a couple of classes afterwards for more practice. But I want to get done with the syllabus content at least, and we could just leave some more practice for after the Eid break then if we need to. Okay, yeah, so we might have a class tomorrow. I'm not confirming that. I still need to confirm this on my end if I can do it or not. If I get permission to do it from my home by night, so I'll need to check that out. But if not tomorrow, then definitely we're going to have a class on Monday. Okay, because then Tuesday and Wednesday might not be possible. So we might have a longer class on Monday in that case. Okay, so we want to get done with the APGP concepts before the Eid break, and then we'll have a couple of more sessions after the Eid break to do more practice questions then. Okay. So that at least we're done with the syllabus content. All right. Now, just a reminder for those of you who are on YouTube as well, I have my past paper session starting from 13th of April. I'll be doing a lot of past papers from the last 4-5 years, from 2020 onward, basically. In those sessions, it'll be around 11 to 12 sessions for each paper, P1, P3, M1, and S1. You can find the link for registration in the description below and also in the chat box on the right side. All the details about the course are mentioned there. I've also posted answers to some frequently asked questions on my Instagram and also in one of my YouTube posts recently. You can have a look at that. If you have any other questions, any queries about the course, you can ask me on WhatsApp or Instagram as well. I'll hopefully see some of you there in that class as well. All right, so that's it for today. I'll see you again in the next class. In the next class, we're starting APGP. It'll either be tomorrow or on Monday, inshallah. All right. And if we have it tomorrow, then we could split it into two parts. Some concepts tomorrow, some concepts on Monday. If we have it on Monday, Monday will be a longer class then. You can expect around 1 hour 30 minutes or 1 hour 30 minutes to 1 hour 45 minutes, in which we will try to complete the APGP concepts. It's another very small topic. We need to spend more time on practice, yes. But for that, I will give you a few days then to practice. And then we could have a couple of classes in that right after the Eid break, inshallah. All right, just to do practice in those two topics. But in terms of concepts, I want to get done before we go on that break. Okay, so that's it. I'll see you again in the next session. Allah Hafiz. Ajay?